Hey guys, we're going to talk about the final review. I've already kind of got it started here. The first question, Coach Buchanan is trying to save money to provide a decent wedding for all three of his daughters. He currently has $10 in the bank because he's a teacher. His plan is to get a bank account with 10% interest on the previous balance each year. Write an explicit function rule and a recursive rule to model the scenario. Well, over here on the right, I've already done that. M sub n plus 1 equals m sub n times the common ratio. That common ratio in this case is 1.1 because we're trying to increase by 10%. The explicit rule is m sub n equals m1 times r raised to the nth power. In this case, m1 is 10 and r again is 1.1. So this is how you would put that answer into question number 1. Question number 2, how much money would he have in 15 years? Well, we're going to take the explicit rule and we're going to replace 15. And if you put this into your calculator, you get $41.77. The next thing that we're going to do, how long would it take him to save 1,500? Well, 1,500 in this case goes in for m sub n. I'm sorry, not 1,500, 15,000. First thing that we're going to do is divide by 10. When you divide by 10, that turns this into 1,500 equals 1.1 raised to the nth power. Then we're going to take log 1,500 equals log of 1.1 raised to the nth power. And what that does is that takes this n right here and it moves it all the way down here in front of log. So I'm going to go ahead and do that. Log of n times, or n times log 1.1. And then in order to finish this problem, we have to take log 1,500 divided by log 1.1. And that's going to equal n. Well, in this case here, you're going to get 76.7 is equal to n. Well, that means 77 years. Because by year 76, we're not going to have enough money. So it's going to be 77 years. What would you have to do in order to speed up his savings? You're going to have to add money each month to the savings account. Add money each month. This is that regular payment that we've talked about in previous classes. The difference between the rate of change for exponential growth and exponential decay, the rate of change r equals 1 point something. So like if we're growing, in the previous example it's 1.1. So in this case you need to add 100% plus the growth percent, or if you're going to decay, r is equal to 100% minus the decay percent. That's the difference between growth and decay. Alright guys, we're going to look at this scatter plot here. You should notice the scatter plot is nonlinear. It is relatively strong. And there's also 3 different cars in this scatter plot. The first one, what car gets the best gas mileage? Well, you want to see which dots are on the top. In this case, it's car 2. What would happen if the gas mileage was, what would happen to gas mileage if the speed was increased to 90 miles per hour? Well, 90 miles per hour isn't over here, but if you notice this curve, it's going to continue to decrease. At what speed is the best gas mileage reached? Well, you want to see at the top of the curve before, as it increases, before it starts to decrease, and it's somewhere around 50 miles per hour. Between what speeds does the relationship show to be positive? Well, if you notice here, that's between 0 and it looks like it starts to decline everywhere after 50. So from 0 to 50. Here it says the relationship is linear. That is false. It is not linear. It is non-linear. It's not a straight line. It's a curve. The relationship shown is very strong. I would say that it is very strong. And then in general, what do we need to look at whenever we are considering a scatter plot? In general, we need to look at form, direction, and strength. Looking at a few more questions. This is talking about, this first question here, talking about cause and effect. Well, the cause and effect relationship here. Students that weigh more carry heavier backpacks is a cause and effect relationship. You have got to be able to define what a cause and effect relationship is based on your reasoning in this example. Just because a student weighs more does not mean they carry a heavier backpack. Their classes could have less books than somebody who weighs less. So this has nothing to do, just because a student is heavier than another does not mean that their backpack has got to be heavier. So this is not a cause and effect relationship. Which of the following is an example of a recursive rule? Remember, recursive rule, the only thing changed in a recursive rule is the common difference or the common ratio. So in this case, it's both B and C. Notice -5 and plus 1.5 is the only thing that's changed. That's a recursive rule. Which is the example of an explicit rule? Well, in this case, there is no, or the first term is given. And in this case, A, we can tell here what the first term is by inputting the number 1 for n. And then in C, it shows here that the first term is given right here. That's where the first term goes. Another way to know this is if there's a common difference or common ratio here, multiplied to n or raised to the power of n. So A and C are both explicit rules. Here we want to write an explicit rule to describe this table. Well, the explicit rule here is m sub n is equal to the first term plus the common difference times n. That is the explicit function rule. How does an arithmetic sequence change? The common difference. An arithmetic sequence changes by the common difference. A geometric sequence changes by a common ratio. Here we're going to be looking at a farmer that's decided to begin raising ostriches. He has a 200 square mile area of land that he can use to raise ostriches. He buys 15 young ostriches to begin with. He has researched ostrich population growth and has noticed that the population will grow at a rate of 0.6 per year. He also noticed that ostrich population is most well maintained when there are at most 4.5 ostriches per square mile. Well, the first thing we need to do is find the limitation. The limitation, here we have a 200 square mile land, and the most that we can have here per 1 square mile is 4.5, so we're just going to multiply this by 4.5. And I believe when you multiply this by 4.5, you get 900 ostriches. So the limitation here is 900. And write a proportional difference equation for this example. I put it up here in general. We have the rate divided by the limit. Well, we just found the limit, so we can change the limit. And the only other thing that changes is the rate. The rate here, it says 0.6 per year. So if we want to type this in, 0.6 divided by 900 times a sub n times 900 minus a sub n. And it's actually plus a sub n, not minus. We here won't identify which situations are linear, exponential, or neither. Jimmy wants to collect as much change as possible, so every time he makes a purchase with cash, he'll put all the change in a jar. His jar, or he begins his collection with 50 cents and is able to save $1.07 in change every other day. How much change will Jimmy have in 1 year? Guys, this is a linear situation because he continuously adds the same amount. A Ferris wheel turns at a rate of 10 revolutions per second. The wheel has a diameter of 50 feet. Guys, right now we're talking about diameter, something that's circular, that's turning. Well, that is neither linear nor exponential. If you remember back, it is sinusoidal or cyclical. Willie has a gigantic fish tank and plans to fill it with all kinds of fish. He gets paid weekly, so he can get new fish each week. He goes to the pet store and buys 5 fish each week for 1 year. This is a linear situation because he adds a constant value each week. Sarah has a goal to raise $1,000 for a charity of her choice. She starts with $1 of her own money, makes a commitment to go out and solicit donations that will double what she has from the previous day. How many days will it take her to reach? Well, she's constantly multiplying by 2. If you're constantly multiplying, it's exponential. Here we have the step function or the piecewise function part. It has the electricity prices right here in this graphic. It says here that up to 1,000 kilowatt hours is 11 cents per kilowatt hour. Here it says more than 1,000 up to 1,500 is 18 cents per kilowatt hour. And anything more than 1,500 is going to be 25 cents per kilowatt hour. Well, this is a little bit tricky, but if the number that we have is under 1,000, we multiply that by 11 cents. If it's over 1,000, we first take the 1,000 times 11 cents and then the difference times 18 cents and then add them together. So the first 1,000 times 11 cents is equal to $110. How much would it cost to use 200? Well, 200 times 11 cents is equal to $22. This is a step function. I'm sorry, this is not a step function. This is a piecewise function. The next question, how much would you be charged for 200? I'm sorry, for 1,200, not 200, for 1,200. Well, again, we take the first 1,000 multiplied by 11, and then we take the next 200, because it's 1,000 plus 200, but that 200 goes over the 1,000 and goes up into the next section here. So this is going to be $36 for the 200 over 1,000. So this is $146.